Hello, this is Scotty with XanderCat, and I have a presentation today on baked lighting in Unity. Disclaimer, I am not a lighting expert in Unity. I am somewhat new to doing baked lighting in Unity, so this was somewhat of a learning exercise for me, and I've prepared a series of rooms to take a look at with different lighting configurations. If you are new to Unity as well, or baked lighting in Unity, you might learn a few things from this presentation. Or if you have more experience with baked lighting in Unity, I'd be happy to hear your feedback on how you recommend doing baked lighting in Unity. And as well as if you have any feedback about any of the configurations I've set up here today. So what I have here is a series of small rooms which I have built using sort of a modular construction approach where I have panels that create the walls and floors and ceiling. And then I have, in most of these, I have a single area light inside that extends to the edges of the walls. Two other elements that will be involved in each of these are whether or not contribute global illumination has been set on the walls, floor, and ceiling panels, and whether or not there is a probe volume inside of the room. So I'll be using adaptive probe volumes on most of these for light probes, and we'll take a look to see what each of these does. So the first room, there's no contribute to global illumination set, there's no adaptive probe volume. The area light was positioned about 0.3 meters below the ceiling, and you can kind of see the light from the area light is extending onto the terrain below. And if we look inside the room, you'll see it is pitch black. There's nothing to pick up the baked lighting in the room. Moving to the second room. In this one, I've now set contribute global illumination to yes on the panels for the floors, walls, and ceiling. There's still no adaptive probe volume. Area light's still about 0.3 meters below the ceiling. We look inside, and you can see now that the panels have been set to contribute to global illumination. They are illuminated by the baked lighting. And there's also a barrel in here to demonstrate an item that still it does not have contribute to global illumination set on it, so the lighting is not being picked up on the barrel. The barrel looks black. And you can also see, because the area light is a little bit below the ceiling, you have that dark edge on the wall and the dark ceiling. It's picking up some light, but it's still pretty dark, and that's probably not ideal. You don't want to set contribute to global illumination on items that might move in the scene, dynamic items. You only want to set it on static items, because if you did set contribute to global illumination on something that moves, like this barrel, once the lighting's baked and you move the barrel, the lighting's going to stay the same on the barrel, and there's going to be a shadow left behind that won't move with the barrel. So you don't want to do that. But that's where the adaptive probe volume will come in, and we'll see that when we add a probe volume. So next room, this time we have contribute to global illumination turned off again on the panels, but this time we have our first adaptive probe volume inside the room. So let's take a look, see what that looks like. And this looks pretty good. What's happening here is these walls are not picking up the baked lighting anymore, at least not from the baked light itself, but rather it's picking it up because of the probe volume. Same thing with the barrel. We have a visible barrel now that looks right. Looks pretty good. However, as you can see, we've once again got light going straight through the walls onto the terrain, potentially into neighboring rooms. So this is probably not what we want. You could maybe use it in special cases where you just have a single room you're doing, but probably not really what we want. So let's continue to the next one. This one, now we've just turned on the contribute to global illumination on the panels. And we also have the adaptive pro volume area light still in the same place. And now we have not too bad of a room with lit walls, a lit barrel that's being lit by the pro volume, walls lit by the baked lighting with the contribute to global illumination. But we still have that dark rim at the top and on the ceiling because of where the area light is positioned. So how can we potentially address that and make that look better? For starters, let's try moving the area light up to right against the ceiling and see how that looks. So the area light is just below the mesh, just barely, and that took care of the ugly dark rim around the edge, but we still have a darker ceiling. So this is better, and this might actually work okay, especially if you have a ceiling that's a different texture, where maybe you don't even notice that it's darker just because it's a different texture and a different color, and maybe that's fine. So that might work, but still not ideal, I don't think. So let's move on to another configuration. What if we put the area light above the ceiling? In this case, some things can go through the back faces of meshes, things like raycasts, and if it's got a collider, like a plane collider, you can go through the back side of a plane collider. Can an area light, baked light, shine through the back face of a mesh? No, it cannot. It's pitch black in here. So that's not going to work. And it might not have lit up the face of the ceiling anyway. So, but it was an interesting experiment. So let's try something different. This time, I have like a dual panel on the ceiling. So there's like one layer that's like 0.1 meters thick of ceiling, and then there's another layer that's 0.1 meters thick of ceiling. There's essentially two layers of ceiling panels. And what I've done is I've taken the lower half of the ceiling and turned off the contribute to global illumination. So it'll pick up light, hopefully from the pro volume, while the top half of the ceiling does contribute to global illumination, which will block any escaping light, or so we hope. So let's take a look what that looks like. And you can see we've got not quite what we were hoping for. There is some anomalous coloration on the edges. If we didn't have that, it would look pretty good. Now, could this be something where you could tweak the probes to get it to look right? Maybe? I don't know. But it's not the easy solution we're hoping it might be. Another potential problem using this is just because now that my contribute to global illumination top panels are only 0.1 meters thick, the walls are getting thin enough that the baked lighting is starting to bleed between the seams in the modular tiles. You can see sort of that lighter line edge, which you wouldn't see on the other ones. These ones, the wall's thick enough. When the wall gets too thin, you start getting some light bleed between the panels, so that's something to watch out for as well. So this lighting, not quite what we're hoping for either. Let's try something different. This time we're going to use two area lights. I've moved it back about 0.3 meters below the ceiling, and now I have two otherwise identical lights, but one is facing up, one is facing down, and I have set the facing up area light to be half the intensity of the one facing down. So let's take a look at that. And not too bad. There's still a little bit of a darker band at the ceiling edge because of the lower intensity on the upward facing light. If you make the intensity of that upward facing light the same as the downward facing light, that difference will go away and it'll look consistent, but then the ceiling will actually look, in my opinion, too bright with the full intensity hitting the ceiling with the light so close to it. I don't have a demonstration of that in this, but yeah, if you turn up the intensity to get rid of that band, then you have a ceiling that's pretty bright. That might not be ideal either. But we're getting closer to maybe what we would like to see. So let's try something else. This time we're going to move the area light back up so it's like right against the ceiling, and still dual lights facing opposite directions with the upper light still at half the intensity of the lower light. Let's take a look at that. So there you go. This looks pretty good. This is about what we were wanting, at least initially. Everything I think looks pretty good in this one. There's no bleeding light anywhere. Pretty good. But there are some potential issues that could crop up. And this one, let's say you have some ceiling details, crown molding, or just other details on your ceiling such that it's not just a flat plain ceiling. In this case, I've added one sort of trim edge in one corner just to see what happens, which is this in this corner over here. And maybe this is okay, but because our downward facing area light is now clipping the trim, you're getting a pretty dark edge under that trim piece. Maybe that's not ideal. It's okay, but it's probably not what we want either. Is there something different we could do there? Maybe. So in this one, what if we move the area light to the center of the room? In this case, I've moved the upward and downward facing lights directly to the center of the room and set their intensity the same now. Let's take a look at that. So now we have, now my concern with putting it in the center of the room is I was worried there would be a visual anomaly right at the edge of the area lights in the center of the room, like maybe a darker band. But I'm not seeing that in this test. It looks pretty good. And we've eliminated that dark shadow under the trim now because the light's now in the center of the room and not at the top. You could potentially run into similar problems with other furniture or details in other spots in the room. So it might just depend on the layout of your room and what types of models and furniture you have in your room. But that's a way to potentially address the shadows on ceiling details. So what if we want to do something a little fancier and add a little more artistry to our room? Maybe add a lamp on top of the barrel, and where we have sort of a brighter area where the barrel is with still good ambient light in the rest of the room. So what I've tried here is to use a point light, which you can set to baked. And I've done that here and added a point light at the barrel, a little bit different color, a little more intensity to make a little more visually interesting lighting in the room. And it looks pretty good outside, but you'll notice we once again have a light bleed problem when using a baked point light. I don't know why that's happening, but that's a problem that I have no idea if you can even fix that. But that makes me not want to use point lights that are baked. How can we potentially address that? Another scenario I set up was, instead of a point light, what if we then use two more area lights to sort of simulate a point light? You can set an area light to be a disc. So in this case, I've instead created two discs above the barrel, one facing upward, one facing downward. Let's see what that looks like. The light bleed problem is gone on the outside. And if we come inside, it looks pretty good. But it looks like, for some reason, with the discs, we are seeing the problem I was worried about, where we have what looks like sort of a darker band at the edge of where those discs are. So if I were to turn on, you can see that's right at the edge of where the discs are. And it looks like it is just a little bit darker. So you could maybe address that by rotating the discs to try to make that band fall on a less visible area. Maybe that would be an approach. But this is probably the scenario that I like best right now. And I'm still considering what else I can do differently with baked lighting. So hopefully you learned something from that, or if you have more feedback and have other ideas about how to do baked lighting or how you do baked lighting in your projects, would love to hear it. Thanks for watching.